minimum number of branch circuits required for a one-family dwelling is 4. This is based on the National Electrical Code, specifically Section 210.11c. This section outlines the requirements for branch circuits in dwelling units. These circuits are essential for providing power to various areas and appliances within the home. Understanding these requirements is crucial for safe and compliant electrical installations. Let's delve into the specifics. Firstly, a minimum of 220 amp small appliance branch circuits are required to serve all receptacle outlets in the kitchen, pantry, breakfast room, dining room, and similar areas. These circuits are intended to power small appliances such as toasters, coffee makers, and blenders. Importantly, no lighting outlet should be connected to these small appliance branch circuits. Secondly, at least one 20 amp branch circuit is required to supply the laundry receptacle outlet or outlets. This circuit is dedicated to powering laundry appliances such as washing machines and dryers. Thirdly, at least one branch circuit is required for bathroom receptacle outlets. This circuit serves the receptacle outlets in bathrooms. There are specific rules regarding ground fault circuit interrupter, or GFCI, protection for these outlets, which are intended to protect against electrical shock hazards in damp locations. These are the general requirements. There may be additional requirements based on local codes and the specific layout of the dwelling unit. Now let's talk more in depth on each of these required circuits. The 220 amp small appliance branch circuits, as mentioned, are for the kitchen, pantry, breakfast room, dining room, and similar areas. This requirement ensures that there is sufficient power available to operate the various small appliances typically found in these areas. By having two separate circuits, the load is distributed, reducing the risk of overloading a single circuit. It is important to note that while these circuits serve receptacle outlets in these areas, they should not be used to power lighting outlets. Lighting should be on a separate circuit. The 20 amp laundry circuit is crucial for powering the high demand appliances used in the laundry area, such as washing machines and clothes dryers. Because these appliances typically draw a significant amount of power, a dedicated circuit is necessary to prevent overloads and ensure safe operation. The code requires at least one 20 amp branch circuit to serve the laundry area. This circuit should only supply receptacle outlets intended for laundry appliances. Finally, the bathroom circuit is for receptacle outlets. Bathrooms are considered damp locations, increasing the risk of electrical shock. Therefore, the National Electrical Code, or NEC, mandates the use of ground fault circuit interrupter, or GFCI, protection for all receptacle outlets installed in bathrooms. A GFCI is a device that monitors the current flowing through a circuit and quickly interrupts the power if it detects a ground fault. This helps to prevent electrical shocks and save lives. The bathroom receptacle circuit should only supply receptacle outlets within the bathroom. It should not be used to power lighting or other appliances outside the bathroom. It is worth noting some general provisions that apply to branch circuits. Firstly, the size of the conductors must be appropriate for the overcurrent protection device. For example, a 15 amp circuit requires a minimum of 14 American wire gauge, or AUG, copper conductors, while a 20 amp circuit requires a minimum of 12 American wire gauge, or AUG, copper conductors. Secondly, all branch circuits must be protected by an overcurrent protection device, such as a circuit breaker or fuse. The size of the overcurrent protection device must match the ampacity of the circuit conductors. This protects the circuit from overloads and short circuits. Thirdly, all branch circuits must be properly grounded. Grounding provides a low impedance path for fault current to return to the source, helping to prevent electrical shocks. Fourthly, all wiring methods and materials must comply with the NEC. The NEC specifies the types of wiring methods and materials that are permitted for use in different applications. Fifthly, all electrical work must be performed by a qualified and licensed electrician. Electrical work can be dangerous, and it is important to ensure that it is performed safely and in accordance with the code. Understanding the requirements for branch circuits is an important part of electrical safety. By following these guidelines, you can ensure that your home's electrical system is safe, reliable, and compliant with the NEC. It is always best to consult with a qualified electrician if you have any questions or concerns about electrical work. Let's recap those points. Firstly, a minimum of two 20-amp small appliance branch circuits are required for kitchen, pantry, breakfast room, dining room, and similar areas. Secondly, at least one 20-amp branch circuit is required for the laundry receptacle outlet or outlets. Thirdly, at least one branch circuit is required for bathroom receptacle outlets with ground fault circuit interrupter, or GFCI, protection. These are the basics to ensure safe wiring in a one-family dwelling. It's best to consult the most up-to-date version of the NEC and local codes because they change. Also, it is important to note that these are minimum requirements. Depending on the size and layout of the dwelling unit, additional branch circuits may be necessary to meet the power demands of all appliances and equipment. It is always better to have more circuits than fewer, as this reduces the risk of overloading circuits and causing electrical problems. Here's how to ensure your electrical plans are solid. Firstly, conduct a load calculation. This involves determining the total electrical load of the dwelling unit, including all lighting, appliances, and equipment. This calculation will help you determine the number and size of branch circuits required to meet the power demands. Secondly, plan the layout of the circuits carefully. Consider the location of all receptacle outlets, lighting outlets, and appliances. Group similar loads together on the same circuit to balance the load and prevent overloads. Thirdly, use the correct wiring methods and materials. The NEC specifies the types of wiring methods and materials that are permitted for use in different applications. Be sure to use the correct materials for each circuit to ensure safety and compliance. Fourthly, install ground fault circuit interrupter, or GFCI, protection where required. The NEC requires ground fault circuit interrupter, or GFCI, protection for receptacle outlets in bathrooms, kitchens, and other damp locations. Install ground fault circuit interrupter, or GFCI, receptacles or circuit breakers to protect against electrical shocks. Fifthly, test all circuits after installation. After completing the electrical work, test all circuits to ensure that they are working properly. Use a circuit tester to verify that all receptacle outlets are properly wired and grounded. Sixthly, hire a qualified electrician. Electrical work can be dangerous, and it is important to ensure that it is performed safely and in accordance with the code. If you are not comfortable performing electrical work yourself, hire a qualified and licensed electrician. Let's consider some special situations. Firstly, for dwelling units with electric heating, additional branch circuits may be required to supply the heating equipment. The size and number of these circuits will depend on the size and type of heating system. Secondly, for dwelling units with central air conditioning, a dedicated branch circuit is required to supply the air conditioning unit. The size of this circuit will depend on the size and capacity of the air conditioning unit. Thirdly, for dwelling units with swimming pools or hot tubs, additional branch circuits are required to supply the pool or hot tub equipment, such as pumps, heaters, and lighting. These circuits must be ground fault circuit interrupter, or GFCI, protected. Fourthly, for dwelling units with attached garages or outbuildings, separate branch circuits are required to supply the electrical loads in these structures. The size and number of these circuits will depend on the electrical demands of the garage or outbuilding. In summary, adhering to the NEC requirements for the minimum number of branch circuits in a one-family dwelling is vital for safety and compliance. Remember that these requirements are minimums, and depending on the specific needs of the dwelling, additional circuits may be necessary. Always consult the latest version of the NEC and local codes, and consider consulting with a qualified electrician to ensure that your electrical system is safe and meets all applicable requirements. It's not just about meeting the bare minimum, it's about ensuring a safe and functional electrical system for the occupants of the dwelling. The electrical system is the backbone of modern living, providing power for lighting, appliances, and countless other devices that we rely on every day. A well-designed and properly installed electrical system is essential for a comfortable and safe home. The minimum number of branch circuits ensures that the load on the electrical system is properly distributed, preventing overloads and reducing the risk of electrical fires. The requirements for ground fault circuit interrupter, or GFCI, protection in bathrooms and other damp locations are crucial for preventing electrical shocks. By following these guidelines, you can help to protect yourself and your family from electrical hazards. Also, it's important to remember that electrical codes are constantly evolving to reflect new technologies and safety standards. Staying up to date with the latest codes is essential for electrical professionals and homeowners alike. The NEC is updated every 3 years, and it is important to consult the latest version to ensure that your electrical work is compliant. Finally, consider energy efficiency when designing your electrical system. Use energy-efficient lighting and appliances to reduce your energy consumption and save money on your electricity bill. Install timers and occupancy sensors to automatically turn off lights when they are not needed. Consider using solar panels or other renewable energy sources to generate your own electricity.